Today's agenda, I'm just going to spend a minute or two talking about webinar logistics. I'm going to do a brief introduction to Greenchill, and then after that, this is my favorite type of webinar because I get to lean back and relax and hand things over to a couple of experts who are going to present to you about secondary loop remodels using existing DX equipment. As always, we're going to do our best to leave 15 minutes for question and answers at the end. Just a little bit about webinar etiquette. Webinar is being recorded, and our purpose in recording it is to make it available to other people on the Greenchill website after the fact. So if you enjoy the webinar and you know of people who you think might enjoy it but they couldn't attend today, please feel free to direct them to the Greenchill website under Events and Webinars. That's where we have all of our archives. What I'm going to do now is I'm going to centrally mute all of your lines just to try to cut down on the background noise that we sometimes get. Now, when I do that, obviously our speakers are going to have to press #6 to unmute their lines, but I'm going to go ahead and mute everyone now.
Muted your line. To unmute your line, press #6.
So you should all be muted, but obviously I hope that you can still hear me. If you all take a look down at the lower right-hand part of your screen, there should be a little hand. If you have questions during the webinar, if you could click on that little hand, let me know. I will wait for an appropriate pause kind of for the speaker and kind of call on you and so that you can ask your question. Also in the question and answer period, if you click on that little hand, why don't you go ahead and experiment, click it on so that I can make sure that it's working for all of you. I don't know, is the hand not working? There we go. Okay. I did. Yep. All right, Jay. Okay, so the hand is working. Obviously, if you do have, once you click it on after you're done asking your question, then you have to click it on again to make your hand disappear. Otherwise, I will think that you have another question. So I'm going to just keep kind of here up and down through the participants while our speakers are doing their presentation to watch in the background to see if anybody has any questions. When you want to ask a question, you will obviously have to hit #6 to unmute your line. Otherwise, we won't hear your question. Okay, so for those of you who are new to Greenchill, Greenchill is an EPA partnership program with food retailers. Our mission is to reduce refrigerant emissions. We have 3 main programs: a corporate emissions reductions program, where companies sign up with Greenchill and commit to measure their refrigerant emissions on a yearly basis, and they set goals to reduce those emissions. We have a store certification program, which was designed to give recognition to individual stores that use technology and practices to reduce emissions to achieve certain standards. We have silver, gold, and platinum levels. And then we have our advanced refrigeration program. Our webinar series is part of the advanced refrigeration program. There we develop best practices, hold webinars, hold partner partner roundtables that are just for our partners. That's where we kind of provide partners and the industry with tools to help reduce refrigerant emissions. I'm seeing here, I'm not sure how to pronounce your name. Knut Georgie, your hand is up. Are you having a problem getting into the webinar, or question already? No? Okay, all right, good. Just wanted to make sure you weren't locked out or something. Okay, so our speakers today, we have a distinguished panel of speakers who have all been through a couple of these projects to remodel existing stores, turning them into secondary loop systems using existing DX equipment. Our first speaker is Rob Arthur from CTA Architects and Engineers. We have several people on the line from SuperValue. We have George Ron is going to be speaking, and Ken Galbraith is going to be speaking. Obviously they're the stars of the show. And I in our rehearsal yesterday, I was just constantly thinking that these are incredibly impressive projects, and I think you're really going to learn a lot at this webinar. So okay, I am going to hand over to Rob. And Rob, thanks much for being our speaker, and go ahead.
All right, I'm unmuted the phone. Can you hear me, Keely?
Yes, I can.
Okay, perfect. All right, let me share this. Are you seeing the beginning of my presentation there, Keely?
Yes, perfect.
All right, well, I'll get started. We'll put an introduction. I'll kind of lead this presentation, but George and Kevin will give their input and experiences on these projects. But we also have, there's others that excited and were involved in these projects, and as people have comments, bring them up so that we can get the most out of it, because I'm involved in a lot of aspects, but in every aspect, so there's some specifics that I might be able to provide. So Keely did the introduction. George and I will have the part in this. Kind of for this is just to discuss the purpose of the projects, why they were even created. And this is a kind of schematic design where we started developing what these systems may look like and how it may work, and then we'll get into when we implemented them into projects and how that went. So this part, I'll let George speak about a little bit because it's something that he manages, but SuperValue has a R22 initiative that has multiple sectors. But George, I'll let you speak a little bit about that.
My pleasure. We do have an R22 initiative in SuperValue. We're focused on looking at ways that we can reduce or eliminate R22 in remodel projects. Want to reduce the leak potential in all of our R22 stores, keep them as tight as possible. So we've got some projects that we're looking at that, and we're looking at the reuse of existing equipment. A lot of stores that come up for remodel we have not met their full life on the rack systems or the compressor systems in the store. We're looking for ways that we can reuse that equipment in non-DX mode, if you will. Turn it into a system where we can save refrigerant charge, 1, 2, or reduce the leaks. So that was kind of the focus of this portion of the R22 initiative, and really a little bit more about the store counts and how we arrived at the projects that we chose.
And we did want to kind of focus here to maybe, because I'm sure this question will come up in a lot of people's heads, that this approach was not an energy conservation measure. From experience, and there's both sides out there that comment on this, but we felt from our experience with do glycol systems that in comparing to the system we're out there running today, there wasn't a big energy penalty, and in a lot of cases we saw energy parity. So I know some others have had different results than that. Those are the results that we have had. So it's really a factor in our decision-making, and we just want to bring that up at front. And if questions or comments on that, people can bring that up. So we started out with and integrated design sessions, and so basically the owner, supervisors, consulting engineers, CTA, and I'll speak, there's also Lopez Engineering that was involved in another project, manufacturer being Health Phoenix, contractor, Aztec Energy Partners, and a refrigeration contractor actually in all three projects that we went through that the CTA was involved with Hussman. So it was a good mixture of the industry. So here's the type of systems, a picture examples of the type of systems that we were dealing with. Stores that had single compressor units. So basically, this is just a bunch of single compressor systems where we have one compressor hooked up to a lineup of 48 feet of dairy cases or whatever it might be, but it's a single compressor hooked up to a lineup, piped to a remote air-cooled condenser. The other scenario we had was a typical rack system that we would see, where we had 2 to 3 parallel medium temperature and 1 to 2 low temperature racks in the store. Obviously, we're focused on just on medium temperature in the process, but those are the types of systems that we went into. So as part of the schematic design, we started discussing the components of the secondary system, and chiller skids, which is basically, and I've got some schematics and pictures of these here a little bit later, but basically a chiller skid is a scheme in with the heat exchangers on it. There were no compressors on this skid. The compressors were all existing on our existing rack, so this is just the heat exchangers for glycol. Pump skids.
Yeah. Also on the webinar? Yeah. Okay.
Okay. So
this is key. If you weren't you're just coming to the webinar, if you could mute your line for us, please, to cut down on the background noise. Sorry, Rob. Thanks.
Oh, that's all right. So the pump skids, which are for those that have done secondary glycol systems, and you'll see in the pictures, they're standard pump skids that have all the different components that we need for a hydronic system. And then the parts were the control valves. And so we have control valves for the direct expansion section of the systems, our expansion valves, our chillers, and then our glycol system had control valves too, being the circuit setters and the T-silides that were controlled by temperature sensors. And then there was a lot of discussion on controls and how we would do that, and I'll get into that a little bit when we start talking about individual projects. The component was the piping, and our options were basically or copper, and either copper or press fit copper, but those were our piping options. So here's just kind of a schematic. This would be of the first picture I showed you, where we had single compressors tied in, and we had a chiller skid that is where we pipe the DX system and tie to the hydronic system, and then we had the pump skid that would then pump glycol to these chillers in parallel, and then out to the display cases or cooler coils. Just a schematic of the scenario where we had parallel racks. So we had these racks with 3 to 4 compressors on and multiple heat exchangers. So in this scenario also we had one heat exchanger per rack. So in this scenario we had a heat exchanger per compressor because they were all single systems, but in this scenario we had one heat exchanger per basically suction group or compressor rack. And so that was just a schematic of the 2 different examples we had. Here's just some conceptual pictures of, and this is rack here that you should be able to see. That's the scenario where we have multiple single compressors to a rack more like chiller skid, more like this, where we've got just a couple larger heat exchangers that are tied to the parallel compressor racks. Here's a better picture of the one that's tied to the parallel compressor racks, where, and this was actually a schematic from one of the shopper stores that we did, where we had basically 3 racks we were tying into. R22. And pump skid, just a schematic of that so you get a point of reference of what we have. Basically, pumps that were sized at 50% capacity of the water flow capacity and typical for or glycol system. So as far as project implementation, to identify these projects, and so the RD2 initiative group, and there were multiple people at Supervalue that were part of that. George is leading it, but there was project managers, there were engineers, so a whole different group of people that put the store list together, and it was a pretty lengthy store list at the beginning. I believe it originated from stores that had heavy crates, but then also were up for remodel. So how we kind of pared down to a smaller list is we obviously have stores with high heavy crates, but the store had the part plan of the remodel was that we were going to replace all majority of the media temp cases. It didn't make sense much to do the project where we had a lot of media temp cases that weren't going to be replaced. The money just didn't factor out when we had that scenario. But then also the other scenario was, as George mentioned earlier, we had compressor systems that weren't ready to be replaced. They still had life and wanted to sell those also. Now we got down to about 6 stores. There's 4 listed here, but there was 6 or 7 stores that it was on to, and actual designs were done on, and those designs were then priced. And after that pricing came through, 4 stores were selected and moved on to construction and completion. So the store in Klamath Falls, Oregon, 577, that was the store with the single compressors. And I'll go through the store in a little more detail. Store 6715 in San Diego, California, was a store that was done with Supervalue and Lopez Engineering was the refrigerating engineer on that project. And then the 2 Shoppers projects in Baltimore and in Burke, also some that CTA and Supervalue were involved in. So to kind of get into some specifics, the store 577 in Oregon, it multiple single compressor systems. They were in a vintage of 15 years old, maybe pretty close to 20, but in this area they were in really pretty good shape. Didn't have issues with them, and we're looking to do this project in. Each single compressor was tied into a heat exchanger on this what we are calling a chiller skid. So each compressor had its own heat exchanger. Like the picture showed, the design, the pump skid with dual pumps on it. I'll just kind of break away from this PowerPoint real quick and bring a refrigeration legend just to kind of give people a concept of the design. So this is the refrigeration legend that was for 577. Pretty similar to what we're all used to. They identified all the different circuits that we want to have, calculated from the case cut sheets, the BTU requirements, and then here are GPM flows. There we looked at what, we were able to determine the pressure drops from for each lineup, and we're also then able to suggest a balance valve setting. Now, and we'll talk about this more later. These are definitely recommended settings. They weren't default settings, and some others can speak to that a little bit, but this was a good starting point. And then from on, I just slide over here and typical stuff, but here's the compressors that were all single systems that are basically tied together. And then just a quick floor plan layout. It's hard to see it if I pull it up, but this just shows the piping, where the loft stations went. We have our end of loop balancing valves. So for those of you that have done some glycol systems, some pretty typical information there, but wanted to kind of show that it's not drastically different than what we'd start from scratch with new glycol systems. So, you know, we did the design, and then phasing had to be considered pretty extensively on how we have enough load to start up our chiller system, and in the case of this 577 store, how we get load off of one of these singles so that we can then use it to start up the glycol. And so it's something, I won't go into the details of all that because we won't have time to, but it's certainly something I just wanted to point out that has to be thought about. And obviously it's something you think about in a standard model, but it has more emphasis here in this scenario. As far as construction and operation, I basically did some interviews of folks that were involved in construction, from contractors to the controls people, and then talked with the maintenance folks that have, you know, been in charge of these operation of these systems since they've been started up. And 577 has been going the longest. We've got to be pushing a year on that project, pretty close. And the feedback we got was that definitely there's more time up front needed for getting the piping in the store. So there was spend the shoppers projects, which will be some of the next slides here, just to build that into your schedule. And one of the comments was you counting that guy in there running those pipes and getting some of that stuff done 6 weeks in advance of you wanting to start up any system. So that was some of the stuff we got from construction. And then, you know, when they got started up, there wasn't any problems with getting product to temperature, increases to temperature, but we did the cycle counts on the compressor and even cycle counts on the point valves that, you know, weren't where we'd want them to be. But and I'll get into how that was resolved, but the system operated and kept the product at the temperature we were wanting immediately, and didn't run into any problems there. So some of the specifics, you know, as far as extra cost on equipment, it really was just the difference between, or the pump skid and the chiller skids, and depending on manufacturer and what buying power have, you know, that would range. So I didn't really list any costs there, but that's really the only adder we had in equipment costs. In this store, we stayed with R22, and we were able to reduce the charge by 40% in the store, and there, so we have these multiple systems. 5.7, we have had zero leak rate since the conversion. Now, a couple of them with higher rates than what their average was, and that just kind of comes down to we had a leak, and over the period of time was shorter than the average was considered before. But the point to bring up here is I thought it proved kind of our whole point of doing this is even the higher leak rate on a couple of these compressors, since we reduced the charge so dramatically, the actual amount that we leaked was less than what we would have previously leaked with a small leak rate percentage. So and that's part of the thing is we reduced our leak potential by eliminating all the piping and stuff out in the store where we can get a leak. We'll reduce our charge, which then when we do have a leak, amounts to less refrigerant being released to the atmosphere. So we already tested it, and it proved to be beneficial in that area. So just some actual pictures of the 5.7 store. So this is the chiller that was shipped in and has the multiple heat exchangers on it. just a picture, kind of a backed up picture there of it. And then the picture I showed earlier, but basically these are all single compressor units that tied into each one of those heat exchangers. Only used 7. Some of these were low temp, so not utilized in the end, but or utilized going to the secondary system. But just kind of so you have a reference of what we had there. Here's just a picture of one of the valve stations on top of the cases. So pretty standard what people are used to that have been involved in glycol systems. But that cylinder is controlled by a temperature sensor in the case, and either closes for because temperature satisfied or closes for defrost. And then here's a picture of a circuit setter that's mounted inside the case. And those are the ones I was talking about that we, as engineers, sized and set we would size what size a valve would be and then gave it a recommended set point, but something that, and they used that for startup, but then was something that was adjusted later for better performance. So the next 2 projects were fairly similar. They were both shoppers projects in on the East Coast, and we had parallel compressor systems there. We had multiple chiller heat exchangers, but again, it wasn't 1 per compressor, it was 1 per rack, and the pump setup was the same. Here we did a little bit different because we wanted to identify costs a little bit more, and it'll show this on the slide, but we did it as if we weren't going secondary, as if this remodel was happening, the new cases we were getting, and just what we've done with a typical design, leaving it all DX. And then we went and redesigned it in this application where we did a secondary design. Where that was just for bidding and equipment costs, but we really wanted to see what the cost difference was on bidding, and I'll get to that here on the next slide. Again, phasing was important. Here was a little bit different. An existing rack running, existing DX medium temperature systems. When everything piped up, ready to go, charged with glycol, and we basically take a lineup off and start up a new lineup. We kind of just transitioned the load with the systems. Now we had 3 different chillers, so we kind of had some staging. So each one of them have staging capacity with the multiple compressors, but then just them being on 1, 2, or 3 of them gave us some staging capacity too. So, I think I don't know if it was any easier doing it with the parallel racks, but it was just a little bit different. And very similar comments on construction and operation. Need more lead time in there for getting the piping in place. But as the operations went, again, they started up, kept the product at the temps we wanted to, no problems with that. And we had to go back and fine tune it to make it run efficiently. But things worked well right at the beginning. So in these 2 stores, we had reduction of medium temp refrigerant charge by 50% on the 2288 store and 60% on the 2337 store. So pretty significant refrigerant reductions. The leak rates in these stores have been 0 since the remodel. Now I think that's, these stores have basically been online since the later part of last year, so not much time to produce leaks, but I mean, it's a good sign we had a leak.
Rob?
Yes.
Sorry, this is Keely. I just wanted to let you know that you have a little less than 15 minutes left.
Okay. No, and I think we're in good shape.
Okay, good.
And the cost difference was 13% install. So those are, we had prices before and after for both, and so that's a good realistic number. And again, equipment costs for that would have been just out of the pump skid and the chiller skid. Here's some pictures of this is the chiller skid for that was tied into several parallel racks. Again, typical pump skid. We were using variable speed pumps and being able to ramp those down based on what differential pressures we were seeing out at the end of the loop. Just kind of gain energy efficiencies there and have a smooth operating system. So, and I guess before I really get into lessons learned, I can get into control a little bit. The control water system, the sensors were out there. They would control a solenoid like we typically would see. As those opened or closed, change the differential pressures out through the system. It then would change to how the pumps would run, and that's really completely separate from the control of the compressors. They were looking at the supply water temperature, and I don't know if I have some specifics, and I talk in a sec on how they did it, but basically they made the controller think that trying to match a load, they tried to thinking at a pressure they were trying to maintain, and so there's just some and they did there to make that work, and so instead at first things weren't. There was a lot of cycling of compressors and even of solenoid valves, so they went back, got the superheats figured out, and that settled down the compressor cycling, and the superheats beyond the expansion valves there on the chillers. And then we looked at, or the controls and the field folks looked at cases, solenoids that were cycling a lot, and closed down some so that they had longer run time as far as closed down the circuit setters, so they had a longer run time and really smooth out that. And feedback I've got from that's been involved is that these systems now are running very smooth. Product temperature is very stable, and it's just been successful. So getting into the lessons learned, and kind of here to wrap it up, and then see if we can get some thoughts that were involved. But the compressor loading and the chiller loading, you have to think out at first. And when we were first doing this, we had to think about, especially we had the parallel racks, were we going to bring on enough load to even get one of the chillers to operate properly? But that was just, work with the manufacturer and engineers kind of going back and forth and figuring out, and then getting with the contractors and let them know, how many cases we needed to start up at one time. Asking for equipment and installation, that definitely was something that, especially shoppers projects, that the project manager put there was something to point out was there was a 6-week or a little more time that he felt you need to get someone in there working so that at the end of that time you'd be ready to bring something online. What that we're kind of learned is we can have a hybrid of a DX system and a secondary system, and we have that where we would do some coolers because the coils just had been recently replaced or were in good shape, couldn't by changing out those coils, so they stayed on the DX system, run the same rack that was chilling the alcohol system. So, and you could even do that. We learned you could do that. You could do your change out in phases where, you do a portion of it because you only plan on changing out so many cases, but as you build your pump system and your basically your piping system, extra capacity, your refrigerant capacity is going to be there because it's just going to switch from doing it as direct expansion to doing it as second. So it's something that could be staged even outside of the project. And then we learned that we eliminated some leak potential, and that was just by reducing the amount of copper refrigerant piping in the facility, and then for sure reduced our refrigerant charge. I would say you could probably just count on 50% as a good average. And I covered this already. Final setup of expansion valves and circuit setters. That's something that needs to be done and done after everything's up and running. products in there, then you go back and spend some time, which is different than any other hydronic system. You go back and basically test and balance it. And then something that I guess I'll bring up that is in the that is in and I understand is available today is we can start reusing existing cases and just changing out the coils. There are solutions now where it's affordable to do that, and basically just change out the coil with an existing case. So kind of the end of what I had. So we'll take questions, or maybe I'll to George or Kevin first, and they can give some quick thoughts on their experiences.
Been here. This is George. One of the things that, of course, you know, as we'd like to be able to say, oh, we did everything perfect right from the very beginning, and as good as Rob's people are and the construction people are, one of the things I think that led us to some of the extra refrigerant leaks that we had in 577, which was the first store, was we didn't really address any of the existing gasketing on receivers and filter canisters, liquid side filter canisters and suction side filter canisters, the pressure controls, all that was existing and remained pretty much existing. All we did was essentially shorten the piping from circuiting all the way out onto the sales floor to an evaporator case to over to the pump skid to the liquid plate E exchanger. So I think, you know, forward in our future projects, we're definitely going to pay more attention to that, replacing gasketing, rebuilding valves, you know, replacing pressure controls, things like that. So, and I think that was the key in the two shopper stores. Both stores we converted from 22 to 404. So we had to replace the gaskets in those because they would have just leaked like a sieve when you remove the R22. The gaskets would have shrunk and we would have had leaking system. So I think it's one of the lessons learned is that we needed to, you know, even though we're using existing compressors, we needed to spend a little time doing some additional gasket changes and stuff like that to make the systems tighter. I mean, the projects are going great. The stores, I've heard nothing but compliments from the store as far as the of the product in the cases. I mean, you're not seeing the same heat levels that you would normally see during defrost cycles, so your product integrity is a little better in the glycol system than maybe we see normally in a DX system. And it's overall, I think it's going really, really well. You want to add anything to that?
Yeah, the funny thing was that we were looking at different piping techniques for future projects. His alternatives to copper out there was some drawbacks, and especially in my scenario, we have a fairly good timeline, and something we're looking at alternatives to right now. That's all I had to about it.
Great. Well, this Healy again. It's really interesting. I love this concept. Rob, I think I heard you say that reducing refrigerant charge by about 50% is certainly within the realms of a project like this. If that's the case, theoretically, some of these stores could qualify for Green Chill Silver Level Source certification, couldn't they?
Yeah.
I mean, we didn't change out the air conditioning, so still.
So it's still using. That's right. If it's using R22, you can't. Okay, yeah, that'd be a big factor. Okay. Maybe you guys might have mentioned this, and I may have just missed it. But understanding this correctly, that you actually closed the stores down to do this, or were you able to keep them open when the remodel was going on?
They were open,
yeah,
for sure.
They were definitely open. That's one of the phasing transition issues that Rob was pointing up, is that you know, you have to find a way to keep the produce available for the customer while you're changing out the cases or the dairy or the meat, whatever it happens to be. So
Okay. How'd that go? I mean, did you get any feedback from the store managers, that they felt that this was done, with as little disturbance as possible, or is it to do something like this in a store, can you factor on a big disruption in sales?
I don't know that we had a huge disruption in sales. It's more a matter of getting the signage up, pardon our dust kind of things that you put up during the period. The store managers hate it, of course, because they'd like it to happen overnight, and something like this just doesn't happen overnight. But there's, I guess, a little bit of extra labor on the store's part, when they're pulling cases and restocking cases after they've been replaced and things like that. But that goes whether it's a DX to DX remodel or DX to glow. I mean, there's always phasing and dust and labor and extra ace for the store, and they're excited when it's done, and they hate it when it's happened. So.
Okay.
I guess just that, and I don't know if Paul Hart or anyone else was on the phone that maybe were involved in that part, but my understanding was it was a real concern, especially in the shoppers projects, of that. But a lot of discussions and the manufacturer and the contractor just figured that out before it was to get you, and as far as it went, pretty smooth. I mean, or no different than like Joe said, the normal converted switch out of cases. Okay,
great. Well, let's open it up to questions from others. There have to be questions. Please, again, just click on that little hand that's down there in the lower right-hand corner. Don't be shy. That's what these webinars are here for. And these guys have volunteered their time to share all of this with you, so it's a perfect opportunity to ask them any questions that you can think of. Nobody's a question. There we go. Nick from Food Lion. Go ahead. Yes, now I can hear you. Go ahead.
Okay. I was curious. I guess since you're reducing your overall charge size, that per the EPA, this would not be considered a new system, and you'd still be allowed to use Virgin R22. Would that be correct?
It matters, but we didn't. I mean, we reused the existing R22. We recovered it from the singles and then reused it. So, I mean, that was all in compliance. I don't know about using Virgin. We didn't do it in any of these projects.
Yeah. Yeah, and to be honest with you, since I'm not from the regulatory side, and I specifically am pretty careful when it comes to the specifics of the R22 phase out, I hesitate to give you an absolute answer at that for fear that I may be wrong.
Okay.
But if you are thinking about a project like this and you want to get a definitive answer from the EPA regulatory people about, kind of on the question, so what's the deal? Do we have to use reclaimed R22 or can we use virgin R22? Feel free to send me those questions. That's what I'm here for. I can get you an answer and clarify that ahead of time, so that you're covered in the area. Yeah.
All right. Thank you.
Sure.
And I think this was kind of another sector of supervised R22 initiative. In both these examples, where we removed the R22 or we reduced it, that was then reclaimed and was available for the other stores that might need it that were in operation. So that's the benefit, is you have now refrigerant. If that's part of your program, is to store for other facilities that you have.
Great. Any other questions on this? McFadden, go ahead. you have to press #6. Mike?
There, can you hear me now?
Yeah, I can hear you. Go ahead.
Has anyone given thought to reusing suction lines for one of the glycol supply or return lines? Is there a way to clean them out to reduce or eliminate contaminants?
Think about that, but exactly what you said there was the concern was that we would not be able to get, all the oil and all those contaminants out of the system, and it's something that could be considered for future projects, but not here. And we basically did it in a loop pipe type system and didn't have individual circuits.
Right.
But no, I think that's a good comment
to clean it up.
A tough challenge for phasing with reusing a typically existing loop to try that for a new glycol line.
Okay. Did that answer your question, Mike?
Yes.
Okay. Thanks. Hey, good evening.
Hi, this is Jay from Arnett. Just reusing the pipe seems that would be a definite way to be more of an advantage going, with glycol. Could be some sort of filtration system as you're pumping that would clean it out. Possibly that start up.
Mind that we're going from single circuit piping to a glycol loop, so really not routed where you need them to be.
Well, yeah, maybe not.
Certainly require a lot more glycol.
This application from this particular store. How many you may stores out there that could warrant reusing the existing piping? Depending on runs are. If you have a loop refrigeration line as well.
Sure.
If
I
you
definitely
have or engineered copper in the cases, that's pretty good size. Go ahead.
Again, it's a good comment because it's something that should be, and it's possible that could even make this more advantageous. We just aren't ready to take on also this kind of experimental project. But I totally agree it's something that could be looked at.
Great. And Mike, did you have another question, or is that just your hand still up from last time? Okay. All right. Any else? On. Go ahead and you press #6 for us. Ron? Yeah, I can hear you.
Great, thanks. Yes, presentation, guys, thanks. I hinted that the goal wasn't energy, but can you give us any indication on where it went? Is that something you want to share? Or?
George, do you want to answer that? Or I can give based on what we talked about.
It's a bag, to be quite honest. And it's fortunately none of the 4 stores that we did are sub-metered on the refrigeration, so we can't really say definitively what attributed. We've done lighting changes as part of remodel, how it affects decor and all that. The 2 stores that we did in the Baltimore-Washington region, are both down slightly on energy use. The store in Klamath Falls, number 577, that one is up ever so slightly on energy use, and I think the San Diego store is neutral. So, there's not, as Ron pointed out earlier, when you add a pump skid, you're taking essentially the same compressor horsepower and reusing it.
Yeah. And
you're adding a pump skid, so you're going to have additional energy devoted to that pump skid. So if you can reduce cycle counts because you've got a more stable load on the plate heat exchanger than you would on multiple evaporators and cases. That's certainly going to help your energy by reducing cycle counts and run times on rack compressors and whatnot. But it was tackled. It was from our perspective, it wasn't tackled as an energy measure. It was more, how can we deal better with the systems in the stores? We're using the existing equipment as best as we can, as well as reducing refrigerant charge and reducing the opportunities for leaks. So.
Yeah, it sounds like you weren't penalized anyhow. Super. Thanks.
Yeah. Yeah, great. Any other questions? Let me ask one. When I guess the first store that you were going through, and you said that you stayed with R22, I think I had misunderstood the beginning. So these are all R22 stores, and was the goal to still be able to use R22, or on any of them? Did any of them start off as HFC stores?
They were R22 stores, and the Oregon one, and maybe Mark can say what happened on or Kevin can what happened on the San Diego store, but the one we stayed the R22, and the intent was just to be able to reduce that charge, and then the other two stores, shopper stores, inverted.
For show as well, those R22 and dues.
Okay. Well, thanks for clarifying that for me.
The two former Washington stores were R22 on medium temp, but they were the HFCs on the low temp.
Okay. Well, it sounds like I think what impresses me the most about these systems and these store remodels is that it seems like there's so much flexibility. You kind of did, you tried out this in the one store, well, that wouldn't work in the other store, so you tried a little something different. It just seems like the potential is lost here because of the flexibility that you have, from the ground up of the project.
Yeah, as far as able to have the hybrid systems, where you've got some circuited DX and some secondary, you just have a lot of opportunities to do different things and set it up different ways. So it's going to be a store-by-store basis, which all remodels really are. And so it takes a little more forethought up front and planning, but surprisingly it wasn't difficult on the engineering side, and from feedback we got from the field and the controls, it wasn't anything that was just, they said they'd never do again. I mean, actually after they got through the initial, like, oh, this is kind of different, like, oh, that wasn't that bad. And so it's been, pretty positive feedback. And, and where it went to energy penalty and we could eliminate that factor, I think, if we came back and saw huge energy increases, have to rethink if it was even worth it. But with eliminating that factor and the goal being to that R22 either by reducing or eliminating, I think the projects accomplished that. They could accomplish it for anybody.
Okay. We only have a couple minutes left. There are two other hands up here. So, Mike, our buddy from Hannaford, do you have a question? I think I have to hit #6.
I did. I hit *6
There
first.
we go. There you go. Now we have you. Go ahead.
That's a great presentation. It's great to see you sharing it with us. My question is on the final lesson learned, or circuit setters. Did you set those valves by temperature or by flow?
By flow. I mean, what they did was identified, we had that preset number, and that was just by looking at the charts and and such, and went with that. And then after the store was up and running, they looked at how often those valves would cycle, and from there would basically start closing it down to where you still maintained temperature. Temperature was a factor, but that your cycling that solenoid was a reasonable amount. And it basically said then now we've got. I mean, ideally you would, if you could just maintain flow all the time other than defrost, and you could set it that perfectly, then that would probably be your best scenario, because now you've got the least amount of flow that you need just to maintain the temperature. But to that your question, I mean that was how they did it. They closed it down and reduced the flow until those cycle counts were minimal.
Okay, so you went by cycling counts then. Okay, good. That's great.
Great, thanks for the question. I see one other here, Mark Dannhauer, a good German name. Go ahead.
Hello, this is Don Hauer with LLS. I was involved in store 6715 in San Diego when we installed the glycol system. I did a couple of comments. That was a really good presentation, Rob. One thing that I did find design was that we'd have to increase the horsepower on the axle to satisfy the BTU load. And, that wasn't a real big problem. And during or after the construction, after we phased out all the old DA systems, the contractor came in and installed new headers, which removed all your old valving and all the old components, which are a really clean and trouble-free project at the end. So
great.
Other than that, everything turned out really smooth, and an additional time that they had to spend on the glycol system at night, but with the connection with the store, they were able to meet time frames for the following day. But other than that, everything was great.
Okay, great. Thanks for your input. I think we're going to have to close now. It's 3:00. Thank you everybody for attending, and thank you very much to our speakers. Thanks to Rob and Kevin and George from SuperValu. It was a fantastic presentation, and I appreciate that SuperValu is willing to share this with the rest of us. Because let's face it, I know Greenchill focuses a lot on new store construction, but the environmental impact of the existing base of stores that are out there already is much, much greater just in terms of numbers. So we're always looking for fantastic opportunities to make existing stores more environmentally friendly. So, and this is a perfect example. What sounds like a great set of projects to do just that. So, again, thank you to Rob, George, and Kevin. And for all of you attendees, if you have any follow-up questions, feel free to send them to me, and I can make sure that they get out to our technical experts. If you have any know anyone who you think wants to listen to the recording, feel free to let them know that it should be up on the website in a couple days. So have a good afternoon, everybody.
Thanks for hosting.
Oh, my pleasure. My pleasure. Okay. Hey, everybody.